Hi everyone, in this session we are going to learn about Kirchoff's voltage law, which is represented as KVL. Let us take a circuit which should be a closed one. Here a voltage source is there which is represented as Vs. It contains two terminals, positive and negative, and some resistances are connected like this. First resistance is R1. Let us assume the voltage across this is V1. Next resistance R2, the voltage is V2. Next resistance R3, voltage is V3. What Kirchoff's voltage law says is the algebraic sum of voltages in a closed path is 0. Okay, algebraic sum means with sign. Okay, when we traverse through a closed path, there are some elements, sources, where the voltage rises. That means when you are traversing, if you are moving from the negative to positive terminal, then it's a rise. Rising voltage, if you treat it as a positive one, then Vs is positive. Next, if you are traversing in a resistance, the voltage drops. So here the entering terminal you have to treat it as positive and leaving terminal you have to treat it as negative. So there is a drop here, that is V1. Next in the resistance R2 it will be V2. Next in the resistance R3 it will be V3. So it is 0. So Vs is nothing but V1 plus V2 plus V3. Suppose let us assume a current of I is flowing. Okay, and I am representing this as one equivalent resistance these three resistances I am replacing with a equivalent resistance which is R equivalent. From this we can write Vs is nothing but I into R equivalent, because we have represented by one resistance I into R equivalent. What is V1? V1 is the voltage drop across R1. What is the current flowing? Current I is flowing through it, I into R1. V2 is nothing but I into R2. V3 is nothing but I into R3. So if I cancel I and I, R equivalent is nothing but R1 plus R2 plus R3. If you see, these two resistances have only one common junction. These two also will have one common junction, and at that common junction no other element is connected. Then these elements are said to be connected in series. If n elements are connected in series, then equivalent resistance is nothing but R1 plus R2 plus R3 up to Rn. Here three elements are connected in series, so equivalent resistance is R1 plus R2 plus R3. Suppose if n elements are connected up to Rn like this only, then R equivalent is nothing but R1 plus R2 plus R3 up to Rn. Suppose if any number of elements are connected in series, then equivalent resistance is nothing but sum of all the resistances. Then let us derive what is the voltage in this particular resistance in terms of the input voltage source. V1. What is V1? V1 is nothing but I into R1. Okay, what is I? I is nothing but Vs by R equivalent. If I substitute R equivalent as R1 plus R2 plus R3, that means if some elements are connected in series, then voltage across one element is nothing but input voltage into that element resistance by sum of all the elements connected in that circuit. Similarly, V2 is nothing but Vs into R2 by R1 plus R2 plus R3. V3 is nothing but Vs into R3 by R1 plus R2 plus R3. Okay. Similarly, if n elements are connected, voltage across nth element is nothing but input voltage into resistance of nth element by R1 plus R2 plus R3 up to Rn. This is the voltage across any element, if provided they are connected in series. Next, I am taking an example where we will find what is the current and voltages. Here voltage division is going to happen because the elements are connected in series. The voltage which is supplied, input voltage, will be divided across the individual elements. Next, I am taking an example. Okay, there is a source and 3 elements are there. First element resistance is 6 ohms, next 3 ohms, next 1 ohms, I am assuming. So here voltage source is applied, there is a closed path, definitely current starts flowing. Let us assume that current as I. Okay, if you apply Kirchoff voltage law here, this is the positive terminal, this is negative terminal. Here we have marked current as clockwise direction. So in the resistance, the current enters at positive terminal and leaves at negative terminal. There will be a drop. So if I apply here, there will be a rise from negative to positive terminal. That means 10 minus. There will be a drop across resistor. Okay, what is the drop? I is the current flowing here. Voltage drop is nothing but current into resistance. 6 times I minus, in this same current is flowing, but resistance is 3 ohms. So the drop will be 3I. Next, here the drop will be I. So if I solve this equation, I got I as 1 ampere. That means this current is nothing but 1 ampere. Next, what is the voltage across 6 ohms? What is the voltage across 6 ohms? Is nothing but I into 6. I is 1 ampere into 6 ohms. It will be 6 volts. What is the voltage across 3 ohms? It is nothing but current into resistance. Current is 1 ampere into 3 ohms. It will be 3 volts. Next, what is the voltage across 1 ohm? It is nothing but simply you can calculate the current in the loop as well as voltage across each and every element. Thank you.